here I have the equation of a curve, and I need to find the tangent and normal lines at this point here, radical 3 comma 2. So again, I don't have y all by itself, so I can't just do my normal differentiation. I'm going to have to use implicit differentiation, and it's going to involve, as always, implicit differentiation is really just using the chain rule. So since I have sums and differences over here on the left side, I think I'm just going to rewrite this. Now I'm going to rewrite it, kind of stretch it out, but I'm going to say I want d to dx of x squared minus the derivative of this term right here, which is going to be d to dx radical 3xy plus d derivative of y with respect to x of 2y squared equals, well, I know that the derivative of 5 is equal to 0, so I'm just going to call that 0 right here from the beginning, if that's okay with you. So let's work through this. I have the derivative with respect to x of x squared. That one's pretty straightforward. That's just 2x. Now, this derivative here, a little bit more complicated. The first thing I want to do here is I see that I have a constant. So I'm just going to pull that constant through the derivative. And so I know it's going to be radical 3 times the derivative of that piece right there. Well, that piece right there is a product. And if you're, I'm going to write the product rule right over here. It's uv plus uv and the u prime, v prime. So I have x and y. So let's write the equation. I'm finding the derivative of x and y. So the derivative of u, that is my x, is 1. And that's times y. Plus u, which is x, times the derivative of y. So that's going to be, well, the derivative of y, if I just kind of look at it again, if I had y alone to the first, and I tried to find the derivative of that, I'd use the power rule, and I'd have, make it an arrow, I'd have 1y to the 0th times, again, because y is its own function, the derivative of y with respect to x. Well, y to the 0 is 1 times 1, so this is just 1. It's just a derivative of y with respect to x. So this becomes x times dy dx. So putting that back into my longer equation here, it's radical 3, I moved that over, and it's times y plus x dy dx. Plus, the derivative over here, I have 2y squared. So that's going to be, I can pull the 2 through it, so it's going to be 2 times the derivative with respect to x of y squared. That is 2y dy dx. So this whole thing is 4, 2 times 2, y times derivative y with respect to x. So I'm going to replace this thing right here with that. And this whole thing equals 0. Now I need to get every term that has a dy dx on one side of the equation. So let me first expand this out. I have 2x minus radical 3y minus radical 3x dy dx plus 4y dy dx equals 0. So I want to get this term and that term onto the other side because the other two terms have dy dx. So I have negative radical 3x dy dx plus 4y dy dx is equal to, well, this would be radical 3y, that's positive, minus 2x, that's negative because I added to both sides that, and I subtracted from both sides that. So now that I've isolated my dy dx's on one side of the equation, I am going to use a distributive property and pull them out. So I have dy, the derivative of y with respect to x, times negative radical 3x plus 4y, and that's equal to radical 3y minus 2x. Let's divide both sides by this, minus radical 3x plus 4y minus radical 3x plus 4y. And I have the derivative of y with respect to x is equal to radical 3y minus 2x divided by negative radical 3x plus 4y. So that's the formula of the derivative, and I need to find, well, what is the slope of my tangent, that is the derivative, at the point radical 3, 2. Well, let's go here. So I'll write down the point. I am at the point radical 3, comma 2. Let me just double check that, make sure that's the right point. Yep, radical 3, 2. So I have radical 3 times my y value, which is 2, minus 2 times my x value, which is radical 3, divided by negative radical 3 times radical 3, again my x value, plus 4 times my y value, which is 2. So I have 2 radical 3 minus 2 radical 3, wow, as my numerator. I could stop right there, but I'm not going to. And this is divided by 6. Well, let's do it right. Radical 3 times radical 3, negative radical is negative 3 plus 8. So I have 0 divided by 5, which is, of course, 0. That is the slope right at this point that they gave me. Well, I know if I have a 0 slope, then the equation is just the value that's going through the y point. So it's going to be 2. But if I just want to just prove it to myself, I would have my tangent is y minus 2. That's my y1 value at the point radical 3, 2 is equal to 0 times x minus radical 3. So I have y minus 2 is equal to 0. Y is equal to 2, the equation of a horizontal line. And if I want to find the normal, well, I can't do a reciprocal of 0 for my slope, but what that means is I have a horizontal line. And I have a horizontal line that is going through this point right here. Well, that has to go through the x value radical 3. So the normal line we'll have the equation x is equal to radical 3. It's a perpendicular line, it is vertical.